Lesson 2, Building a Network. At the conclusion of this lesson, you should be able to identify the path or paths connecting two devices in a simulated network, and you should be able to explain how computing devices can be connected to form a network. As a warm-up, think about this. In the previous lesson, we explored the internet simulator where each of you were connected to one other person by a single wire. What are the potential problems with this setup? Jot down your answer to this prompt in your notes. Pause the video while you do that. Okay, hopefully you paused the video and now you're back. Here are the two biggest problems I see. One is the need to be able to talk to multiple people at one time, as we did or do in Zoom, and as you do just any time. There's so many times when we want to talk to multiple people, you want to send an email to multiple people, not just one. You also have to have the need for a backup. What if there is a wire that is damaged or unable to transmit information? You don't want just one way to talk to someone. You want to have some backup, some redundancy. So we're going to create a human network. If we're in person, you and your group should have pieces of string. Virtual, you and your group should have access to the Google Slides, which is in the assignment, or which is in the lesson. Click on it and you should be able to receive a copy of the Google Doc, okay, or the Google Slides. Now, guidelines for all of the challenges that we're going to do in this lesson. Only two people can be connected by a single string. You can be connected to multiple people at the same time via multiple strings. So I can only be connected to one other person, one string, but I can have multiple strings that go to multiple people. Now, with that in mind, first challenge. You can access the Google Doc and do this on your own if you're not in class, because in class you'll be put into groups. But if you're on your own, you're going to create a network where everyone can speak directly to everyone else. Look at challenge 1. Give yourself a few minutes. I would set a timer for about 3 minutes and see what you come up with. While you're doing that, please pause the video. Now you're back, and hopefully you have your network. Does it look something like this? Okay. You connected to everybody. Everybody, you connected a string and everybody connected to you. Fantastic. But here's the guidelines. Strings, just like networks, cost money. So you want to try to use the least number of strings possible. But you want to create a network that uses the least number of strings, but so that you could talk to anyone in the network. Okay? Again, pause the video and try this challenge. Give yourself about 3 minutes. Pause and resume. Does anyone have something drastically different than this? If I'm here, if I'm this person and I want to talk to this person, my message simply has to go around the loop. Likewise, this person could come all the way back here. Everybody else can go one of two ways around the loop or around the network. But now here's the next wrinkle. Strings cost money, so we need to use the least number of strings possible. Guideline 2, a string can be cut, which might disconnect people from the network. So now, I'll give you 8 minutes on this one because this is a little bit harder. You have to keep both Guideline 1 and Guideline 2 in mind. And then you want to create a network that keeps everyone connected, even if one of the lines is cut. So if you take away one of the lines in between two people, but everybody can still talk to everybody else. You may have to go around a little bit farther, but it still works. Okay, pause the video and try building that network. And now you're back. Did everybody come up with something like this? Okay, if you came up with something like this, notice if I cut this line, then for this person to talk to this person, it would have to go all the way around, and vice versa. But everybody can still get to everybody else as long as only one line is broken. If two lines are broken, then you've got some problems. But you do have a little bit of redundancy. Now, challenge 4. This is the big one, and so therefore you'll have 10 minutes. What you need to do is create a network that you feel balances all 3 guidelines. The fact that strings cost money, so you want to use the least number possible. At the same time, knowing that they could be cut, and so you want to make sure that people can all stay connected even if something gets cut. And then guideline 3, direct connections are much faster than long paths with indirect connections. So remember when we started at one point, we had to go all the way around for connections? That slows stuff down a lot. So we want to try to avoid that where we can. But this gives us 3 different guidelines, and some of them sort of conflict. So what you're going to need to do is balance the cost of more strings with the ability to have faster connections. So as a group, create a network that you feel balances all 3 guidelines well. Pause the video and try this one. Now that you're back, think about the 3 guidelines and what is a strength of your network. What did you put your most emphasis on? So what is the strength of your network? And then likewise, what is the weakness of your network? The fact that you had 3 guidelines and they somewhat conflicted with each other, contradicted each other, anyone's network is going to have pluses and minuses. So state yours. What I want you to do now is, since you can't share it if you're just watching the video, but note what it is. State your strength of your network and the weakness of your network. If you're doing this to gain asynchronous credit for attending class when you're not in class, then please write this down and then give to me either email or hand to me the hard copy, your network with your response. Or we can even meet in office hours and go over it. Now, everyone in class, and I'm sure those of you online, offline, or individually have built some very interesting networks. We're going to talk a little more about how data moves in these networks. Routing is the process of finding a path from the sender to the receiver. Routing. As we've seen here, there are many different paths that a message might take. No one in particular is the absolute correct. How fast a message arrives is determined by bandwidth. In a computing network, the bandwidth is the maximum amount of data that can be sent in a fixed amount of time. This is usually measured in bits per second. If a message arrives quickly, that may be because of high bandwidth. Many bits can be sent per second. If the message arrives slowly, it could be due to low bandwidth. That's because very few bits can be sent per second. So here are 2 definitions, routing and bandwidth. Pause the video if you need a moment to take those down. Now, as we wrap up, a computing device is a machine that can run a program, including computers, tablets, servers, routers, and smart sensors. A computing system is nothing more than a group of computing devices and programs working together for a common purpose. A computing network is a group of interconnected computing devices capable of sending or receiving data. So essentially, a computing network is a computer system. A path is the series of connections between computing devices on a network, starting with a sender and ending with a receiver. Bandwidth. This is the maximum amount of data that can be sent in a fixed amount of time, usually measured in bits per second. Bandwidth is typically bits per second. Now, thinking about those words, and oh, by the way, I'll pause here. If you need to, pause the video and copy down these definitions so that you have them to study from. Now that you have your definitions, Look at those words and the definitions and think about how you would use those words to describe today's activity. How would you describe today's activity in calling things, what things were computing devices? What was a computing system, a network, a path? Jot that down in your notes. Pause the video while you do that. Okay, this is what I have, a computing device. Each individual person or node, if we were virtual, it would have been the nodes on the paper. In person was each individual person, and the network was acting as a computing device. The path, well, that was simply the strings or the lines that you drew between the devices. Okay? If two people weren't directly connected, then a path may require multiple strings to communicate. To get from here to this guy, or from here down to here, you'd have to follow this path. Computing system and computing network. A computing network is a type of computing system. So those two kind of went together. So what we did when we created our network, we actually created a computing system. Very well done. Now, next lesson, we will be finding out about the need for addressing and why that's important in the internet.